Okay, so now let's share the screen here. Okay, good. Anything else for office hours? Okay, let's do the sort of algorithm-y ones first. And then we'll do the more nodey database-y stuff in a second. Okay, so timing JS functions. Let's go back here. All right, so what it's saying is you do console.time, and then you say some function, then you run the function, then you say console.time end. Ooh, performance.now. Okay, so T0 is performance.now, do something, T1 is performance.now, and then you can say call to do something. Oh, okay, well, whatever. This is just, yeah, it seems kind of lame, but get time, return the number of milliseconds. Okay, so it's basically the same thing as console dot or performance dot now. Don't use date, read below. Okay. This guy or gal really likes performance dot now because it's more standard across browsers. Don't ever use date for anything. Okay. Chill. Console.time and console.time end. Okay, let's actually, I just want to do a search for time a function. I want to do node for timing a function.
Oh, yes.
With callbacks, no. Okay. Okay. Process.hr time. Is that superior to the console? It's a lot more precise, and you can store the result in a variable. Okay, so console.time and console.time end, it prints something like, okay, let's try the console.time and console.time end. Of all the options, that's the one I'm liking best. So okay, let's see what happens. So I'm going to save this as in my presenter, source, new folder, time functions, and okay, so let's see what happens. Okay. Okay, so now we can see that largest digit took approximately 3 times longer than largest digit 3. Yeah, maybe almost 4 times longer. Okay, if we do boy, am I pissing ESLint off. Try this. Okay, so now the difference is even more stark. Took like 5 times longer. No, yeah, 5 times longer. But still, your eye really can't perceive the difference between 154 milliseconds and 29 milliseconds, right? They both kind of look instantaneous.
Should that one matter? Right, so it's not a problem
when you're dealing with large amounts of data. Okay. Let's talk about different ways to merge. So merging, so merging in general, you're dealing with arrays. So if I have, let's go here. So if I have an array, and I have an array that's like array 1, okay, and then array 2, it doesn't make a lot of sense to do anything with these two arrays except to merge them sort of alternating. And the reason is these two arrays are not sorted. So if I were to merge these, like I would just do 2, 2, 3, 6, 4, 32, 23, 62. Do you see what I'm doing? I'm just taking one from one and then one from the other, and then one from one and then one from the other, like I'm merging cars on a freeway. And then 1, and then 6, 4, 2, and then 6, 2, 3, 5, and then 12. Okay, and so now I've merged the two arrays. Things get a little bit more interesting when you're merging two arrays that are actually already sorted. So now if I do this, that's sorted. And if I do this and this, okay, now this one is sorted. And now things get a little bit more interesting because I can merge them in a way so that my final array is also sorted. So talking about algorithms, and this is a classic algorithm because it's how merge sort is implemented, or part of how merge sort is implemented. So how can I merge these? How can I make an algorithm that will merge these in a way that my final list is going to be sorted?
Alternating with questions for new array, you compare the incoming digit and number, with what was in there and like what it's looking for.
Yeah. What do you think, Amin?
Well, if you put them in that order, like array 1 will go, and after that array 2, you do like array dot concat. Right?
You could.
But if you wanna do, depending on the position, I would say maybe slice.
Our algorithm is going to have to be pretty smart in order to end up, because our final object is to end up with 1, 2, 12, 23, 32, 62, 642, 2, 3, 6, 4, and 6, 2, 3, 5. That's our final object, is to end up with that array. So how can we make sure that we end up with a sorted final array? By merging these. And I like what Brittany was saying about sort of selectively choosing which array to pick from, depending on which has a lower number. So this is just in pseudocode. I'm going to look at the first two numbers of each array, and then I'm going to take the one that's lower. And this, by the way, is not ideal runtime-wise, but it's good conceptually. Now I'm going to delete it. Really, you would just keep pointers, but I don't want to deal with that right now. Then I look at the first two numbers. Which one's lower? The 2. Great. So I delete it and I put it here. Which one's lower? The 12. Cool. I'm going to delete it and put it here. Which one's lower? The 23. Which one's lower? The 32. Which one's lower? The 62. Which one's lower? The 642. Which one's lower? The 2364. Oh, this one's empty, so I'm just going to take the rest of whatever this one has to offer. And even if this one had, even if this one had 3 more numbers, I would just take them and put them here because I no need to compare to something empty the whole time. That is part of merge sort. Merging 2 already sorted arrays to get a sorted outcome. It's a good exercise, especially if you like algorithms. Write that up in JavaScript. Given 2 arrays that are already sorted, end up with a third array that is sorted. Did that answer your question?
Yeah. To answer my question is just more if you have if you've been asked in like particular order, like for example, like well maybe from the lowest number to the max number or biggest number, or maybe you have 2 arrays and you want to sort them and merge them in between. So like 1 will go with 12 and 2 will go with 23. So like merging them in a way that
just alternates between one and the other?
Yeah, exactly.
Yeah. So that's
alternate,
just
like different way of alternating.
Oh, I see. That's not something that I've ever heard about.
Okay.
Yeah.
I think when you're doing console time and test, it goes around the implication. I think because when that runs, it's like that's the
Oh, that's just like, oh,
Yeah.
you're so smart. Okay, yes, you're right. That's interesting. Okay, so thank you. Thanks, Dev. So I was just timing how long it took to like define the function, which was a little silly, but it gave me the results I expected. So I was like, huzzah, right? Whereas really what you want to do is time the amount of time it takes to call the function. So thanks, Dev.
Yeah.
Better. Not better? I don't know. Notice how different it is every time. That's why whenever you're doing timing stuff, you want to do it many times, right? Because they have to do with like weird things like what else is happening on my computer at the time. And so, but the fact is that the top one is always consistently taking more time.
There's a tool too called JS Perf, but it's an external tool.
Okay, JS Perf. Is that what you, Celeste, you made a hand signal? Were you looking at JS Perf? Ah, okay. Oh no, what happened? All right, I think we're still okay. No, it stopped recording. What? No, it's still recording. Okay, I'm not sure what happened there. Okay, so, okay. All right, so JS perf might be another thing you can look into. I just want to take the last 13 minutes to talk about relational databases because you can never have enough relational database talk. What is a relational database? Does anyone? That's a philosophical question. What is a relational database? A relational database is a database that is made up of relations. Relations in this case means tables. It means square data. You have columns and you have rows. Rectangular data. You have columns and you have rows. Every row has an entry for every column. Every column has an entry for every row. All that grid of columns and rows, every item is filled. That's a relational database. It is two-dimensional, yeah. Columns and rows. NoSQL databases, such as MongoDB, those they are not relational databases. They don't use tables. The data is not rectangular. Instead, you can think of the data as just a bunch of JSON strings. It can scale better. It can scale better for very, very large data. It's more because of sharding. You always want to have relationships between your data. That's just like part of what databases are used for. But yeah, are you laughing like a 5-year-old would at the word sharding? Yeah, okay. It's SHARDING. It's easier to break. It's easier to break up your data. When you have a table, that table all needs to live on the same drive in order to function efficiently. You can break it up, but it's complicated. Whereas if your data is just a bunch of JSON strings, you can put them wherever. It's a lot easier to distribute your data when you have large data. Yeah, Monica.
Why does that make it easier for scaling? So the more users, the more data, whatever we have, the easier it is to break up. That makes it easier.
The easier it is to break up, that means the less you're going to have sort of traffic collisions about things that want to use the same table.
So I should things like MongoDB and
yeah, what are the NoSQL databases? I don't know. MongoDB is the only one that comes to mind. I know I've heard of others, but let's just look. Versus SQL databases, relational and SQL. Let's see. So Azure, apparently, if you want to go the Microsoft way. So there's an Oracle NoSQL database. Let's see. Yes, there's you want to know about NoSQL, here's the way to do it. Ooh, graph databases, fun.
Also known as like
document databases, yeah, where you're storing it in just those documents, and those documents that contain the JSON, and not in these tables.
Is it the document databases? You said it scales better?
It scales better because it's easier to distribute your data among a lot of drives, and you don't have these like collision tables, because basically you can't really have two processes updating the same table at the same time, right? And so you get these sort of traffic jams. And I think modern SQL databases, you can do stuff without locking. Neo.J4, that's one. Oh no, that's a graph database that I've heard of. But so there's all sorts of just different ways you can do them. And so here are just yeah. So Mongo, where does Mongo Couchbase is one that I've heard of. Is Mongo in here at all?
TeamViewer uses
What's that?
TeamViewer uses RethinkDB.
It uses what?
RethinkDB.
RethinkDB? Okay, so Mongo is a document-based model. Rethink is also a document-based model. Yeah, so you guys can read more about this if you want. Clearly, I am absolutely not a NoSQL expert. So back to relational databases. Relational databases are basically, you have tables and you want to have relationships between the tables. So you guys have probably heard of one-to-one, one-to-many, and many-to-many. Have you heard of that? Can anybody describe to me what those relationships mean?
Just like what, well, let me tell you an example.
Okay.
You can have, so if I made an order, right? I can have so many items in one order.
Okay.
But that item can be in, well, the item can be in one order.
So the item can only be in one order? The item can't be in a lot of different orders?
No, actually, sorry. That's confusing. So yeah, so I have an order. I can have so many items in one order, and I can have many orders with many items, many to many.
Yeah, items and orders would be a many-to-many. Each order can have many items, and each item can be in many orders. Many-to-many.
Like an example for one to many, maybe shopper.
A shopper.
Shopper and order. No, actually.
A shopper can have many orders.
Can have many orders, but one order can have only one shopper.
And an order can have only one shopper. One to many. One shopper, many orders. Each order, only one shopper. In my favorite pets database, many to many, pets and owners. Each pet can have many owners. Each owner can have many pets. One to many, pets and species. Each species can describe many pets, but each pet can have only one species. Celeste, I just don't even want to know what you're thinking about pets with multiple species.
I have to look it up.
Okay. Okay. So, right. So, and one way to think about it is, can I put the ID of one table as a column in the other table? So, for example, if I have a, let's just do a new, and I'll save schema.sql. So let's say I'm doing shoppers. So I'm doing shoppers orders. So we have a create table shoppers, and we have a create table orders, and we have a create table items. Actually, I'm actually going to do my favorite, the species, the pets, and the owners. Okay, and so in the species table, would it make sense to put a column that is a pet ID?
Yeah.
Because each species has only one pet. What would you do if there were two cats? Problem.
Yeah, well, you might do like page 1 and page 2 or something.
Yeah, that's, if you start thinking about doing that, or especially if you start thinking that I want to put an array here, then you know that this table has a many relationship with the other table. If you start thinking what I really want is for pet ID to be an array, then you know that you're dealing with a many relationship to the other table. Traditional databases should not really employ arrays. There are some special exceptions, but in general, no. So here now, does it make sense to do a species ID? Would I ever want more than one species ID here? No. Screw you, Celeste. So, okay. The answer is no. What pet do you want, Celeste?
A mule is an offspring of a donkey and a horse.
Isn't it species mule?
No, because it's not a species.
It can't reproduce. All right. So for Celeste's pet mule, for Celeste's pets, this is going to be a many to many, but for the rest of us, we are going to say each pet has only one species. Okay. So it doesn't make sense to put pet ID here because we might want to have many pet IDs per species. But it does make sense to put species ID here because unless we're Celeste and raising mules, we only want to have one species ID per pet. Okay. For owners, does it make sense to put pet ID here?
Yes.
Why no, Celeste?
Because I have a lot of animals.
Because Celeste has a lot of animals, which means she would want to make this an array.
Yeah, you want
Oh, if I have more than one, so you want these that only have one value.
Right, exactly. So does it make sense to put owner ID here?
They only have one owner.
Well, if the pet is connected with owner, yeah, you want to.
Well, but what I like Brittany's question. What if each pet has more than one owner?
Yeah, that's
So there is no way I can do pets to owners the way I can do pets to species, right? Pets to owners, I can't put owner ID in pets and I can't put pet ID in owners, which means I need an association table. Like a join table. And this table's only reason for existence is to have the pet owner ID, because every table should have a unique primary key, and the pet ID, you think you know what I want, but you don't, and the owner ID. So now, if pet 1 is associated with owner 1, and pet 1 is associated with owner 2, pet 1 will just have 2 rows in the pet owner table. And if owner 1 has 2 pets, owner 1 is associated with pet 1, and owner 1 is associated with pet 3000, then that owner will have 2 rows in the pet owners table. Do you have questions, Brittany?
I'm just trying to picture it. So I don't know. So okay, so like I would have a pet owner ID, like Brittany. No. It'd be like,
No, you would just have an owner ID. So let's actually look, because I've done this more times than I care to admit. So let's go. Okay, so. Okay, so here I have my pet owners, and let's look at my database, and let's look at my schema, or I made this tables. So here we have the species, it's got the species ID and the name, and then we've got the pet ID and the name and the species ID. And then we've got the owners, and it just got the owner ID and the name, and then we've got pet owner. And this pet ID is a foreign key, meaning it has to match an ID in the pet table. Okay, so this is the description of the tables, and now let's look at my seed. So notice first I just put stuff into the species table. Fine. Then I take this and I say Astro is going to have species ID 2. Astro is going to be a dog. Toto is going to have species ID 2. Toto is also a dog. Hobbs is a tiger, so Hobbs has species ID 3. These are just going to get, because my tables, because they have a serial primary key, it's just going to increment the primary key every time. So when it creates this, it's just going to make cat primary key 1, dog primary key 2, and tiger primary key 3.
I mean, never asked that question, but should you start with 1 or 0?
You don't get to choose when you use this, and SQL chooses to start with 1. Good question. Okay, so Astro's a dog, Toto's a dog, Hobbs is a tiger, and Crookshanks is a cat. Then I have all of these owners. Hermione's going to be 1, Dorothy's going to be 2, George is going to be 3, and so forth. Then I'm inserting into pet owners. And what I'm saying here is that pet ID 4, which is Crookshanks, is going to go with owner ID 1, which is Hermione. And pet ID 3, which is Hobbs, is going to go with owner ID 5, which is Calvin. And this table makes it so that George and Jane can both own the same pet, Astro. And if Hermione had another pet, Padfoot, of course, is nobody's pet. But, okay, if Hermione had another pet called Patfoot, then I could say the pet ID is going to be 5 for Padfoot, and the owner ID is going to be 1 for Hermione. So if I want all of Hermione's pets, I'm going to look for owner ID 1. And if I want all of Astro's owners, I'm going to look for pet ID 1 because Astro is my first pet. And there's also joining, which I'm gonna stop now because like we're at 11 o'clock. But there's also joining so that I don't have to like find out the ID ahead of time. I would recommend, I did a lecture on SQL, and I would recommend that you look at that. And if you have trouble finding it, let me know. I actually did some reorg of the YouTube channel yesterday to try and make things easier to find. Okay. Your SQL adventure is just beginning, Brittany. I actually really love SQL. I'm kind of crazy that way.
So why do you love it? If no SQL databases do all those things, feel better and improve solutions?
Because I tend to make smaller programs, and yeah, so 2 reasons. I tend to make smaller programs, and SQL is just so inherently logical. And it's also, I've dealt with actually really large, complicated SQL databases, and it is a tremendous puzzle to try and figure out how to get the data you want in just one query, joining all sorts of different tables, and in the most efficient way possible. I had a job where I was writing a lot of SQL queries against an enormous, complicated database. Super fun. And then the other reason, Brittany, is because I am old school. NoSQL databases are relatively recent. Yeah. So I don't have a lot of experience with NoSQL databases. Maybe I would love them too.